Hi, I'm Madeline James and welcome to the second video in my world building guide series. If you haven't seen the first video, I would recommend going back and watching that first because everything we're going to do in this video is going to build off of the last one. So, starting for this next video, we already have our plate boundaries, we have our main land masses, we have those sorts of details figured out, and the next step is going to be doing large-scale erosion, glaciation, and looking at our physiographic regions. This may not be something that I think is gone into in most world building guides, even one sort of at this level, but glaciation is one of the biggest sources of large-scale erosion that you will see on the planet. Before we get too far into how we're going to apply this glaciation and large-scale erosion onto our maps, we should talk a little bit about the process, and if you find this interesting, I would highly recommend you devote a few hours of your life to just researching this process. You can find a lot of videos of simulations of how this has happened on Earth, and it's very cool. But getting into the mini glaciation science lesson, and again, I have all of these resources referenced in the blog post that's linked below. I was a geology major for a while though, so some of this is just things that I've learned over time, but the most important thing to know for glaciation is that glaciers are really, really heavy. And all that weight is going to compress and flatten the land beneath it. And the other most important thing is that glaciers move. There is circulation processes in how this glacier is created and maintained that basically mean at all times glaciers move. Ice deformation is the microscopic movement of ice crystals. Due to this internal deformation, the weight of the glacier and the pull of gravity will cause the glacier to slowly spread out. There's also typically a layer of water beneath the glacier before the earth, so between the glacier and the ground, which allows the glacier to sort of slide out. Large glacial sheets will spread outwards and smaller ones will flow down valleys. Glaciers also move in the direction that they are sloped, so they're going to go from where they are thickest to where they are thinnest, which is mostly going to be around the edges. This means that glaciers can actually move uphill if that is where it goes from thickest to thinnest. As glaciers move, they can take rocks, boulders, any sort of debris, sediment with them, and that gets left behind as they travel. When large glaciers move, they will literally cut into the ground and leave it raw and scraped. When you look at the, warming and cooling periods of the Earth, not talking about small scale things like what we're dealing with right now, but large scale like ice ages and periods where the Earth is significantly warmer than it is right now, those periods are going to cause large scale growth and receding of glaciers, but glaciers will also have seasonal change as we go throughout the year. A lot of the ways that glaciers can transform a landscape are going to come more into play as we get into the more regional style maps because they'll be a lot smaller scale, but some of them are even applicable at the global scale, which is what we are going to be including now. And I do have a lot of videos linked in the blog post that are just really cool to see all the different types of landscapes that can be created by these. If you've ever visited a northern area like Scotland or Canada or someplace like that, you will probably see a lot of these really cool landscapes. Alright, but let's get into actually applying these. So you're going to want to have a copy of your map, and I just used my printer and made copies. If you're doing this digitally, this might be easier to do with layers. But basically you want to mark your last glacial maximum. And this is going to be the point during the last ice age of how far towards the equator these glaciers and ice sheets extended. You're mostly going to see this extend in areas that are much closer to the poles. They can extend down into more mountainous areas because those are going to be higher in elevation and thus colder. And if you have a wide continent that's in a sort of subpolar region, so like closer to the poles, you're going to see the west coast of them having more glaciers than the east coast. Those are due to wind patterns. We'll get into that more later. But basically, so like in Europe and Asia, you will see Europe. This is probably going to be weird because if you look at it like this, Europe is here, right? You're going to see the glacial maximum on Earth from the last ice age is going to cover most of northern and I think even central Europe, whereas if you look over towards the more like side with like China and everything and Russia, it's not going to extend as far down on the east side. In North America, the last glacial maximum basically went all the way down through Canada into Northern America, and if you look on the southern hemisphere, you really only see it in the Andes Mountains a little bit, but none of the landforms are really southern enough or have enough landmass southern enough, close enough to the poles to really have any significant glaciation in the last ice age. You can of course have your cycle of climate be a little bit more extreme. Maybe your last ice age was more significant than ours, and you can have that go a lot further towards the equator. But I wouldn't go too crazy with this because there'll also be some other effects of this that we're not going to go into, so it might make some of our modeling a little bit more inaccurate, but kind of sticks somewhere around where the last glacial maximums were on Earth, going down into those sort of mid latitudes, and stick with that. Okay, so if I want to know where the last glacial maximums would be, so all of this probably would have been glacier down here, not here, right? It wouldn't have extended this far up, especially because this is water. But then up here, maybe around here. So we'll do here, maybe say here a little bit, and here. So this would be the last glacial maximum. In any areas of your map that in the last glacial ice age, or in the last ice age, you have ice sheets that are over large continental regions, you're going to want to have a source of that ice sheet. And this is going to sort of be a little bit central, slightly more towards the poles, area where there isn't a ton of mountains. And this is going to be where your glaciers are the thickest, or where your ice sheet is the thickest. Okay, and then source areas would probably be, this one would, come from around up here. And we'll say over here would be the big main one, because again, these are connected, so maybe here and here-ish. So next, on the same map, you can sort of mark in some of the glacier-created regions on the map, and then once we do that, we will adjust our landform map. The first thing we're going to mark is the current ice sheets and glaciers. And on Earth, you mostly see these in the northern hemisphere, in the livable continents, I guess you could call them. So you mostly see this in Greenland and a little bit of northern Canada, and you will see this in Antarctica in the southern hemisphere. You will mostly see these in high latitude and high altitude regions. On Earth, we're going to have ice caps extending to about 75 degrees latitude from the poles, and then you'll see tundra areas going to about maybe 60 to 80 degrees latitude and skewed towards area affected by offshore winds. Again, we're not really there yet, but in subpolar regions, which is mostly where these latitudes are, they're going to extend further on the eastern coasts. So right now, this goes to, what is it, 60 to 80 degrees, so I really should probably add in my marks, but this would be 0 degrees, this is 90 degrees, so 45 degrees, 60 to 80, so somewhere up in here-ish is where our current ice sheets will be. So right now, this goes to, what is it, 60 to 80 degrees, so I really should probably add in my marks, but this would be 0 degrees, this is 90 degrees, so 45 degrees, 60 to 80, so somewhere up in here-ish is where our current ice sheets will be. So actually the edges of this probably aren't covered in ice, it's probably just down here. So we'll say like, this is our current ice sheets. I'm gonna go around here. And then up here, it'll probably only be like up here. The next one is one of the most fun ones, and these are, my pronunciation is probably going to be off, but Glacial Archipelagos. And these are basically areas where the weight of the previous ice sheet in the last ice age was so heavy and was over this area so long that it actually depressed the land, so that you basically, instead of having just land that goes to the shore, you have a bunch of series of tons of little islands. You can see this a lot in Canada especially, but you also see this a little bit in Northern Europe and parts of Russia. There's going to be a few places where these are going to apply. So mostly you're going to look at places on the maps where you have, I will put up a graphic, around coasts where there is room for a continental shelf before you run into a plate boundary, where it makes sense for a lot of glaciers to slid towards the sea. This could be in areas where the source of your ice sheet is near a coast and there are no current mountain ranges in the way. And these islands can also be covered in small glaciers, so you might not even be able to see them per se. But I wouldn't even bother mapping these in areas that you have indicated as having a current ice sheet. I would just have these in areas between your current glaciers and ice sheets and the last glacial maximum. Okay, so let's see if we have any glacial archipelagos. Archipelagos, I can never pronounce literally anything ever. Okay, so okay, so potential areas for glacial archipelagos, right? So we're looking for coasts that were around the glacial center. So here, 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 where it would have really compressed the land. So let's see. We can maybe see it a little bit in here where this would have pressed down. Probably not here. I would have expected it to recede this way. You might see a little bit along in here and maybe in here, although this is a little bit south. Okay, I'm gonna say down in here we would have some, mainly around in this area. Gonna do that. Because these glacial sheets would have been focused on mainly down in here and then up here. And while this one would have receded to the current ice sheet, this one would have melted over time. It would have been still pretty big. So I'm going to say right there, we're gonna have some of that, maybe bleeding in around here. I hesitate to do anything here or much here, but maybe the slight right here. And over here. And this will adjust our landform edges because some of this land will have been squished down, right? And then the rest of these regions are only going to apply at all to areas that are not currently under an ice sheet. I would mostly not map glacial archipelagos underneath them because it won't really matter too much unless they extend really far. Next you're going to have lowland regions, and this is going to be in the place where the ground was compressed the most at the source of your glacier. You might see a large lake or a bay here because it's been compressed so much, or it might just be incredibly low. Examples of this on Earth are going to be the Hudson Bay lowlands in Canada and the West Siberian Plain in Russia. This is going to be very dense, poorly draining soil that is not suitable for forestation, and there are going to be a lot of marshes and bogs here. So when we get to those sort of vegetation and soil quality versions of this guide, that's going to really have a big effect because the amount of, agriculture and stuff that you can have in these areas is going to be severely impacted. Alright, so lowland regions. These would be in the source of the old ice sheet where the ground was the most compressed. There could be a large lake or bays here, sort of like what you would see in Canada. So I think I would see that here, maybe. So some sort of maybe like a big bay here, right? And then we would have lowlands. Same thing maybe here. Maybe this one wasn't quite enough to create a bay, but we have some lowland here. Won't have to worry about that here. Okay. The next step is going to be your shield regions, and this is going to be sort of surrounding these lowlands, and this is going to be, if you imagine the sources of these old ice sheets and glaciers are sort of creating like a bowl where the source of that glacier is. This is going to be sort of the edges of your bowl. You might not have a lot of these in your map depending on how it makes sense for the glaciers to have been sitting. This area is basically based off the Canadian shield, and this will be an area where the ground has been scraped very significantly by the glaciers. There's going to be a very thin layer of soil before you get to rock. There will be a lot of rock exposed. The rock that is exposed is going to be, close to the bedrock, very, very old rocks, which is, again, going to come in when we get into minerals and the type of vegetation and agriculture that can be in areas. Alright, and then in here we would have the shield. The lowlands would be surrounding the shields in the bay regions. The next section is going to be glaciated mountain valley regions. For the most part, this is going to be any of your mountains that were currently covered in the last ice age. You're going to have areas where, as the glaciers moved over these or around these, you're going to have deep valleys cut through them. This won't really impact how we draw the map at this global scale, but you're going to want these mountains indicated differently on your physiographic region map because the smaller scale terrain of these mountains is going to be very different. You'll get a lot of lakes, ridges, those sorts of things in these mountains. So we just want to have that noted for now. Next we have glacial interior plains, and this is basically going to be any area between your glacially glaciated mountain valley regions and your shield and lowland regions, sort of like a transitional zone. So you'd have, let's see, interior plains would be these sorts of regions up and around here, probably. And the next one is going to be coastal fjords. Again, for the most part, this is going to really come into play at a smaller scale, but you will still see a change in the coastline at this global scale from this sort of a thing. This is basically coasts of lands where glaciers would have flowed out, and sort of just imagine this a much lower elevation of the glaciated mountain valley thing, where instead of cutting valleys, it's literally carving out the edges of the coast to create fjords where those glaciers are going to really flow into the ocean. Essentially, at this scale, these coasts are going to be really jagged, and there are going to be some larger fjords. A lot of the northern coastlines in the northern hemisphere of Earth look at this. So if you look along the northern coast of Russia, if you look at the northern coast of Canada, on especially the northeastern side, away from the Glacial Archipelagos, and like Scotland and some of those northern parts of Europe as well. You don't see these a lot in the southern hemisphere because, again, in the last glacial maximum, the last ice age, glaciers and ice sheets didn't really extend over the southern tip of South America or into Australia. If the ice sheet were to be removed from Antarctica, it's possible you would see some of this sort of a landscape under there. But on your map, you might have more of this in the southern hemisphere too, but this is going to mainly be around your subpolar regions. Okay, so coastal fjords. Let's switch to just a new shade of purple, right? So anywhere where you would have had a lot of ice going off of. So here we're not going to worry about it because it's probably covered in ice, but especially around here, we're going to say this would have fjords. Up in here, this whole region is going to be very fjordy. Same with, you know, up in here. And basically anything that's left along here is probably going to be pretty fjordy. Next, we're going to have glacial lakes. And like everything, you'll see a lot more of these at a regional scale, but here we'll probably have a few at the much larger scale. And this is going to be areas where there were glaciers or ice sheets in the last ice age, where some of that meltwater could have been trapped. You'll probably want to focus on areas near the last glacial maximum where there would have been a lot of retreating and growth in cycles where these would have been built up over constant melting of the glacier. So if you have any areas where, so say you have mountains like this, right? A mountain range here, and you had a glacier ice sheet that extended to maybe down to about here, you would probably have a bit of a glacial lake down in this area where that water would have pooled as it melted down but couldn't move past the mountains, at least not at a rate enough to drain all that water out. So just, you know, put these in areas near mountain ranges or where mountain ranges are between that glacial maximum and the sea. And you know, you only need a few of these, and it also depends on how much landmass you have around these last glacial maximums. There's a possibility you won't have any of these on your map, or you might have a ton. It depends on what your land masses look like. We'll only add a few of them. So in here, maybe we'll see, maybe like right in here would be a good spot for a glacial lake. So it's a little higher here, so you might have seen one, you know, here. And with up here, you might have seen one maybe in this area. And let's see. Maybe in that region, right? This next one is a little bit weird, and you're mostly just going to mark this so that we can come back to it in a later version or in a later stage, but this is basically outburst flood zones. This is something that I find very, very interesting, but basically when you have glaciers that are spreading and covering area they hadn't been covering before, a lot of these will block off rivers or create ancient lakes that can be very large. And then you can have a lot of effects from this meltwater in general, or when these ice-dammed lakes are unleashed. The biggest one that we know of on Earth was the glacial lake Missoula, which stretched for 200 miles and was 2,000 feet deep. That's really crazy. When the dams or the ice broke from these, you would have a huge catastrophic flooding that would happen as more water than you can imagine was just poured out of these ancient lakes that are just so much larger than anything we currently have on the planet. And as these glaciers kind of grow and recede, you can have a repeating of this process where maybe as they grow, they create another dammed off lake, and then as they recede, it bursts out again, and you're just going to have this constant flooding and carving of the landscape from this epic amount of water just tearing through the landscape. There are a lot of theories and different geological processes that scientists believe could have formed the Grand Canyon, but one of the main events that would have created these are a giant catastrophic flood from probably an ancient lake dam breaking, and this water ripping through the ground, tearing and forming the Grand Canyon, and potentially this happening repeatedly and these canyons just being carved repeatedly over and over and over as these ginormous floods just tear right through the landscape. You will also see this in, I think, the scablands of East Washington. Okay, outburst flood zones. I don't know if I have any. Probably around here would potentially have some outburst flood zones, because I could see water getting stuck in here and then flowing. I could potentially see that in this region too, if there's a lot of ice stuck here and trapped and then it flooded over here. So we'll say outburst flood zone. So these are all our glaciation created features. We'll mark these on our maps first, and then from there we'll start moving into the physiographic regions that would be in areas that were not previously around glaciation. But okay, so this is sort of where we want to put our glacial physiographic regions. We'll actually turn this into a proper map in a bit, but it's good to just have these. Now, these physiographic regions are going to tell us a lot if you haven't already picked up on it. In the elevation that we go into next, these are going to greatly affect that. This will affect vegetation and soil quality later on. This is going to affect wind currents. This is going to affect precipitation and all of our climate zones and all of those things. So this is very important. So the other ones are going to be a little bit more obvious. So what I'm going to do now is we're going to adjust the map where we need to, and I'm just going to make this in red. But let's see. Alright, so those are the areas changed by our slight glacial archipelagos. I'm going to add in this glacial lake, a couple right here, one in here. I think that's going to have a little one there. Okay, fjords, that's going to change the shape, but only for like significantly larger fjords. So this, you know, I'm not going to actually do it precisely. I'm just going to kind of go like that where this would be changed, but I'm going to see this in here. All right. So this is going to be our updated map. All right, so going through and marking our regular physiographic regions, I'm going to just kind of summarize these real quick, and then I will have like a little guide in the side while I go through and mark these on my map so you can sort of follow along with where these regions would be. The first thing we're going to want to mark is our mountains, and these are the ones that are not glaciated mountain and valley regions. These are just regular mountains. Some of these will be created by your convergent plate boundaries. Some of these might be more eroded and older from your previous plate boundaries that are no longer active. The next one is going to be plateaus. Plateaus are formed by convergent plate boundaries as well. You might just have a plateau at a convergent plate boundary, wow, that wasn't severe enough to create a mountain, but it might just start to create some plateaus. You might especially start to see this in a newer plate boundary that is convergent. You may also see this sort of surrounding continental convergent boundaries. So for example, the Himalayas, there's significant plateaus to the north and even a little bit to the south of these. We're only really worried about really large ones, but you'd be surprised how much plateau region there is. The next one we're going to map is going to be coastal plains, and these are going to be flat areas near the coasts. Areas like this are going to be like on the east coast of North America in the United States, where you have a large coastal plain between the coast and the mountain range. Inland plains are going to be a little bit different. They're still going to be relatively flat and low, but not nearly as low as coastal plains, and these will also be further away from coasts, obviously based off the name, but these are going to be areas where a lot of sediment has come down. So if you imagine areas of your map as sort of, we'll get into this more when we get into waters and watersheds and all of that, but all of your mountains are going to drain out, and as all the water from these mountains run out, you're going to have that carry a lot of sediment. So a lot of these plains, like the Great Plains of the United States, who have to run from all of those mountain ranges coming up north and south on either side, coming down into these plains and then slowly going south towards the coast, you're going to have a lot of sediment deposited there, and a lot of this is going to be very fertile land. And then next we're going to have rift valleys, and these are going to be at significant divergent continental plate boundaries. They'll be small and then just areas where, you know, the earth is starting to kind of pull apart a little bit. You might have little bay inlets in these regions, or it might just be some sort of like canyoning or cracking in the ground, some form of rift. And the next we're going to have volcanoes, and we mostly already know where these are. These are where all your hotspots are. These are going to be in subduction zones where there is volcanic activity. And then around your more significant volcanoes, especially ones that are more active, so particularly ones around subduction zones, you're going to see volcanic plateaus as the magma that comes up from these then settles and slowly raises the land around the volcanoes where there is volcanic activity. And then around your more significant volcanoes, especially ones that are more active, so particularly ones around subduction zones, you're going to see volcanic plateaus as the magma that comes up from these then settles and slowly raises the land around the volcanoes. And these are going to be particularly notable because the plateaus that are created by layering magma is going to be a very different composition than continental crust that was smushed up or created by, you know, other types of plate boundaries. So I made a little key. It can be anywhere on your map. It can be on a separate piece of paper for you. It's whatever works. And I'm just going to go through and kind of mark these. So here are our physiographic regions. I mapped them all out kind of based off what we had talked about already. I added in a hillland section, which is just these, which sort of covers the area that isn't quite mountainous, but also isn't really a plain or a lowland yet, so I'm expecting it to be kind of hilly still. So you see that a lot in these areas. Not sure what else much there's to say about this. Alright, so at this point we have all the main physiographic regions from our map. And this tells you a ton of information. A lot of it isn't going to mean anything to you now, but we'll be taking this map and we'll be turning it into an elevation map. We'll eventually be using this to create, in combination with climate maps, our vegetation maps, our soil maps, things like that. This is how we're going to figure out where you have marshes and bogs and plains and grasslands and all these other sorts of features is all going to come from this map. But as you can already tell, next video we will be going into creating our elevation map. If you've been enjoying this video series, please give it a like, let me know, so that I know to prioritize making these videos in the future. Once I go through and finish this guide, I want to kind of go into some more like niche areas of going into how these worlds kind of really impact your people and how you build civilization around them and what sort of histories they might have and events they might have, what sort of religions would be created in these areas based off the land that the culture and the people have evolved in. And it's going to be a lot of fun. But let me know if you have any questions or comments, please let me know below. I am not perfect. I am an amateur. And despite my brief stint as a geology major, you know, I definitely don't have a degree in this. I just really like to Google things. But I will see you in the next one.